Hello my dear class 10 students, how are you all? I hope you all are doing amazing. This is your Ekta ma'am here. In this video, we will be covering all the important chemical formulas. Yes, my dear students, there are around 50 plus formulas that are there in your syllabus, in your entire class 10th chemistry syllabus. Okay, so we will be focusing on the 4 chapters, right? 4 chapters, all the important formulas that are written there. Now, before telling you all these chemical formulas, you should remember how to write those chemical formulas. So here's a quick recap. Before writing any chemical formula, you should know the chemical symbol of that element. You should know the chemical symbol of that element. If you do not know the chemical symbol, then how will you write the chemical formula, right? For the chemical formula, you need the chemical symbol. Next is valency. Valency is the combining capacity of any element, right? That means how many bond an element can form. For example, carbon can form up to 4 bonds, right? And similarly, oxygen can form 2 bonds. That means the valency of carbon is 4. The valency of oxygen is 2. The valency of nitrogen is 3. Clear? So that is the valency. You should remember the valency and the chemical symbol of that particular element. Only then you will be able to write the chemical formula of any compound. Okay, now let's start. Before starting, this is a table, you have seen it, right, in your 9th standard. What is it? It consists of commonly used ions. These are the cations, these are the anions, right, with their valencies. Along their valencies, commonly used, these are the cations, these are the anions. What are cations? Cations are positively charged ions. They are positively charged ions. And then we have anions. What are these anions? They are negatively charged ions. Sodium Na positive, potassium K positive, that is the valency. They have combining capacity of 1. They can form bond with one element, right? Similarly, these are the polyatomic. Polyatomic means they are made up of more than one atoms. For example, ammonium made up of nitrogen and hydrogen. Hydrogen carbonate, hydrogen carbon and oxygen. So remember this table. It has all the required cations, anions and the polyatomic ions along their valencies, which will be very important for your chemical formulas, for you to write the chemical formulas. Okay. Now let's start. How do we write the chemical formula? So we use the valency method. This is the valency method, or you can say cross multiply. Either you can say valency method or you can say cross multiply method. Cross multiply valency method. In this method, what you do, my dear students, you write the cation and you write the anion and then you write the valency Clear? Here both had 2. So what we did, we take common. If both has same valency, so we can just divide it by 2 and we get 1, right? So that means when you combine it, and then what you do cross multiplication. You do this cross multiplication thing. That means CaO has a formula, calcium oxide has a formula, CaO. Okay, let's see in aluminum oxide. We know aluminum symbol is Al, oxygen is O. Valency of aluminum is 3. Combining capacity is 3. Oxygen is 2. So what will you do? You will just cross it. Just cross multiply it. That means the formula will be Al2O3. Firstly, you write the cation or metal, you can say. Then you write the non-metal. So firstly, metal is written, and after that you write the non-metal. One more example we should do for a complex ion. For example, this potassium carbonate. Potassium carbonate, of here we have a simple cation and we have a polyatomic ion. I hope it is visible to you all. Now see, potassium has a valency of 1. This carbonate ion has a valency of 2. So what we will do? We will cross multiply. So we will write K2CO3. K multiplied by 2, K2CO3, CO3 multiplied by 1, CO3, right? So K2CO3 will be your final formula. So that's why I said that table is very important from your 9th standard. So now is the time to revise that table. Okay. Now let's discuss all the formulas starting from chapter 1. Magnesium oxide, MgO, zinc sulfate. See again, how do you write the formula? Zinc and then you have sulfate, right? Zinc has a valency of 2. Sulfate has a valency of 2, right? Both are common, both are 2. So instead of writing 2, you can write 1, 1. If you take the 2 common and then you just cross multiply it, and that's how you get the formula ZnSO4, right? Then you have iron oxide, the formula is Fe2O3, glucose, C6H12O6, very important for photosynthesis as well as respiration. Barium chloride, BaCl2, again, barium has a valency of 2 and chlorine has a valency of 1. If you cross multiply it, we get Ba times 1 and chlorine times 2, BaCl2. Aluminum sulfate. Now aluminum has a valency. This may look tricky, but it is very easy actually. Let me write it for you. If you have aluminum and you have sulfate, SO4, so sulfate has a valency of 2, aluminum has a valency of 3, you do cross multiplication, right? So that becomes Al2, and this sulfate, it is considered, na? Whole atom it is considered. So you write SO4 and that is whole thrice. This is the formula of aluminum sulfate. Then barium sulfate, BaSO4, aluminum chloride, AlCl3, zinc oxide, ZnO. Next, sodium hydroxide, NaOH, sodium sulfate, Na2SO4, calcium oxide, which is also called quicklime or dry lime. Okay, sorry, quicklime. So that is called calcium oxide, and then you have slaked lime or lime water, that is calcium hydroxide. Calcium carbonate or limestone is CaCO3. Methane is CH4, which is a natural gas. Ferrous sulfate, FeSO4. Ferric oxide, again Fe2O3. Copper oxide, CuO. Lead nitrate, PbNO3 whole twice, again NO3. Nitrate has a valency of 1. Nitrate has a valency of 1. Lead has a valency of 2. Lead oxide, PbO, nitrogen dioxide, NO2, silver chloride, AgCl, silver bromide, AgBr, copper sulfate, CuSO4, both has a valency of 2. SO4 also has a valency of 2, copper has a valency also of 2. Next, iron sulfate, FeSO4, lead chloride, PbCl2, copper chloride, CuCl2, that is copper chloride. Again, silver nitrate, AgNO3, potassium iodide, Ki, both has a valency of 1, potassium sulfate, K2SO4, barium iodide, BaI2, again, barium has a valency of 2 and iodine has a valency of 1. It has a valency of 2 and it has a valency of 1. If you cross multiply it, you get BaI2. Potassium chloride, KCl, zinc carbonate, zinc, ZnCO3, again carbonate has a valency of 2. Carbonate, this is a polyatomic ion, CO3 2 negative, it has a valency of 2, and we have zinc 2 positive, it has a valency of 2. So if you crisscross them, you will get ZnCO3. Zinc nitrate, ZnNO3 whole twice, potassium hydroxide, KOH. Next is sodium zincate, Na2ZnO2. It is an important salt formed by the combination of sodium metal with zinc. It is formed by the combination of actually sodium hydroxide with zinc metal, right? A base with an amphoteric metal. Next is sodium bicarbonate. This is also called baking soda. Next, calcium bicarbonate, CHCO3. This is water soluble. Next, acetic acid, CH3COH. Acetic acid also has a name called ethanoic acid. We also call it ethanoic acid. Next, magnesium hydroxide, MgOH twice. Hydronium ion, this is also H3O positive and it is formed by H positive reacting with H2O. So we get H3O positive. Then methanoic acid, again it is an acid HCOOH, that is methanoic acid. That means only one. Meth means only one carbon. Bleaching powder is calcium oxychloride. This is the correct formula for bleaching powder, calcium oxychloride. Okay. Next, plaster of Paris, calcium sulfate dot half H2O, gypsum is calcium sulfate dot 2 H2O, copper sulfate dot 5 H2O is hydrated copper sulfate, it is copper sulfate, ammonium chloride NH4Cl, washing soda is Na2CO3, sodium carbonate, this is sodium carbonate with 10 water of crystallization. Moving on, sodium aluminate, again NaAlO2, which is formed by the combination of aluminum with sodium hydroxide. Aluminum oxide Al2O3, magnesium chloride MgCl2, lithium chloride LiCl, mercuric oxide HgO, both has a valency of 2. Cinnabar is an ore of mercury HgS, copper sulfide which is Cu2S, manganese dioxide MnO2, zinc sulfide ZnS. Then you have from alkane you have methane, ethane, propane, butane, pentane, hexane. It has a common general formula have CnH2n plus 2. If you fit it, all these have the same formula. This is the structure of all these: methane, ethane, propane, butane, pentane and hexane. Next is alkene. For alkene, you have the general formula of CnH2n, right? And you have ethene, propene, butene, pentene, hexene, heptene and octene. Up to 8 carbon we have. That means they have one double bond. These all are unsaturated compounds. Then you have alkynes. Alkyne has a general formula CnH2n minus 2. So you start from ethyne, propyne, butane, pentine, hexane, heptine, octane, up to 8 carbon. And this is the structure. They all have a triple bond. Next, these are the some compounds that were there in your carbon and its compounds. You have acetic acid, which is again ethanoic acid. Chloroform, CHCl3 is chloroform. Ethanol is CH3CH2OH, ethanol, right? Methane is CH4. Again, it is a natural gas. Natural gas composition is methane. Then you have sodium methoxide. It is formed by the combination of alcohol, which is ethanol with sodium metal. Reaction of ethanol with sodium metal gives sodium ethoxide. Ethanoic acid, again acetic acid, ethanoic acid. Sodium acetate is formed by the combination of acetic acid with sodium metal. Acetic acid with sodium metal. And you get this sodium acetate. Now next is ethyl acetate. What is ethyl acetate? It is an ester. It is formed by the reaction called esterification, when you combine an acid and an alcohol. So this is the acid, acetic acid, and this is the alcohol, which is ethanol. So that's why it is called ethyl ethanoate. It is not ethyl acetate. You can call it ethyl acetate also. Ethyl ethanoate. And that was all the important chemical formulas. Just go through them once. If you have any doubt, do mention them in the comment section, and all the best for your boards.